Hello! Today, we will dive into a very important topic for all Flutter developers: exceptions. Exceptions help handle unexpected situations that may occur during program execution, preventing app crashes. So, what is an exception? An exception is an error that occurs during program execution. For example, it could be an error like dividing by zero or trying to open a non-existent file. An exception interrupts the normal flow of the program and can cause it to terminate if we don't handle it properly. An exception in Dart is an object that, like all objects, is inherited from the base class object. Dart provides a built-in exception class, which is used to create standard exceptions. Let's look at a simple example of an exception. We'll try dividing a number by zero. Notice that we are using the division operator with a tilde. This operator divides but rounds down the result, so it always returns an integer. Let's try printing the result to the console and running the program. As we can see, we got an exception because you can't divide by zero. The code after the division won't be executed, and our variable won't be printed to the console. In Dart, we can handle this using the try-catch construct. Here's how it works. Inside the try block, we write code that could potentially cause an exception. Let's put our code inside the try block. As you can see, the compiler underlines try because we are using try but not handling the potential exceptions that may arise inside this block. We can handle them with the catch keyword. Notice that it has something like parameters, and we must specify at least one. We don't need to indicate a type for it, just a name. This parameter represents the exception object that triggered this block. This object contains information about what went wrong and can be used for logging or displaying error messages. Let's output this parameter in case of an exception. Now, let's run our code again. As you can see, this time, despite the exception being thrown, it was successfully handled by the catch block. Moreover, we were able to print information about the error. Let's move on to the finally keyword. Finally allows us to create a block that executes regardless of whether an exception occurred or not. Let's print a message to the console inside the finally block. The code in this block will run in any case. Let's run the code and see what happens. As you can see, we see the text from the catch block because we encountered an exception, and also the text from the finally block, which is always called at the end of the construct no matter what. All exceptions in Dart inherit from the object class, and most of them implement the exception interface. There are different types of exceptions that are thrown depending on the situation, such as format exception, integer division, by zero exception, and so on. This means you can create your own exception classes by extending exception or its subclasses. Let's create our own exception class by implementing the exception interface. I suggest adding a string field that will store the error message. Let's not forget the constructor. Now, having created this class, we can throw our custom exception using throw. This keyword is used to explicitly throw exceptions, whether they are built in or created by you. Let's create a simple method that will check age. It will accept one parameter and check it. If the age is less than 18, it will throw the custom exception we created with an error message. In other cases, we will print a message saying everything is fine. Notice that we don't need to use else because if the age is less than 18, the method will stop executing at the point where we throw the exception using throw, and the program will move on to the catch block, if it exists. Let's try calling this method inside our try-catch construct, passing a value less than 18. After running the program, we see that the code from the catch block executed because our method threw our custom exception. Let's create another copy of our exception class with a slightly different name. I'll explain why we're doing this. Dart allows us to control how we catch different types of exceptions. In the previous example, The catch block handled all types of exceptions that could be thrown by the application. But what if we want to use one block of code for one class and another block for a different class of exceptions? For this, we can use the on keyword. Here's how it works. By specifying the name of the exception class, we describe inside the curly braces how we plan to handle that particular exception. We can use multiple on blocks for different classes, but we can only have one catch block. The catch block will handle all other cases if none of the on blocks match the exception type. Let's run our code and see what happens. As you can see, the code inside the on block that corresponds to the exception type we threw executed. Let's now change the exception being thrown in our method to our second class. This time, the code from the second on block executed. Today, we learned what exceptions are, how to work with them, and how they help us make our applications more stable. We explored error handling using try-catch finally, exception inheritance, and creating our own exceptions. We also saw how to use the throw operator to generate errors. I hope this lesson was helpful. Apply this knowledge in your applications to make them more reliable and resilient to unexpected situations. If you enjoyed this video, don't forget to like it and subscribe to our channel so you don't miss new lessons on Flutter and Dart. See you in the next video.